Welcome back, everybody. So our next activity of OCB 2025 is going to be a virtual career panel. We've really tried to assemble a pretty broad array of science roles across sectors here. And another thing that got pulled together kind of quickly at the last minute, but I'm really excited about it. But Cristina, you are first, so please go ahead.
So thanks everybody for joining. Thanks Heather and May for the invite. I'm Cristina Schultz. I'm an assistant professor at Northeastern at both the Department of Marine Environmental Science and Civil Environmental Engineering. So I work at the Nahant campus, which is this figure on the top here. And if you're at this beach, you can see Boston in the background where the main campus is. So some of the questions that we were asked to answer. First one is if I can get this to, okay. How did I transition to my current role? I applied for the job. I say that as a joke, but like I really wasn't sure where I wanted to go. I considered, maybe trying to find something at NOAA or an NGO. Decided to give it a try. I was terrified of the tenure process, but really hit it off with the people in the department. I thought this was a great opportunity, so I took it. What does a typical day look like? So twice a week, it's not changing, sorry. I commute to Boston, so that's a bit of a commute. It's about an hour to teach. Those days I'm usually just teaching, meeting with students, going around the busy campus, seeing people. Twice a week I go to the lab on this lovely campus here, meet with my group, attend faculty meetings, do actual research, and once a week I work from home to write, prepare classes, exams, grade, review papers, and so on. What skill sets do I use most in my job, and which ones I learned on the job versus which ones I learned through my training? So science writing, papers, proposals, reports, that's something that I was trained to do. Coordinating multiple projects, general scientific thinking, linking ideas is something that I was trained to do. Teaching is something that I got exposed to before. I TA'd and did all of that, but the first semester by myself teaching climate change to 100 people fresh off of grad school was busy to say the least. Mentoring, I did quite a bit before, but it's definitely different when you have a larger group and different people doing different things and just trying to connect everything and keep a coherent research program. Lots of things I'm learning on the job. So you're writing a proposal. What do I need? What are all the things I need to think about? Does something change? How do I go about changing, about reallocating the resources I have? That's something that I'm still learning. Navigating university resources. Someone needs to help me. I don't even know who it is. People heard a lot from me in the first couple of years. Some key advantages, it's very dynamic. Writing proposals is not that scary. It's actually pretty fun. You get a broader view of several topics, new connections, some scientific autonomy to work on things that, genuinely excite you. And I think teaching has made me a better scientist. Going back to the principles and talking about it constantly turns out it's really important. Some of the challenges, it's a lot. I love my job. Sometimes I wish I did a little bit less of it. It is pretty busy, but I'm kind of getting the hang of it. This is my third year. And being called a professor, it confers a certain authority and, like I need to act a certain way now that I'm still kind of getting used to. And what advices I would have for early career scientists in this field? I think big. Like, what are some general questions I have? So I would like to close budgets in the carbon system, the carbon cycle. And then narrow it down, like what can you do realistically? What's something that's feasible that you could do? And build collaborations, take initiative. People genuinely want to hear from you at whatever stage of your career you're at. So don't be shy to put yourself out there and contribute your ideas. Happy to answer any questions. Try to keep it short. Hopefully I stuck to 3 minutes.
Thank you, Cristina. That's great. We are going to skip and go to Lauren as Emily's approaching a computer. So Lauren Linsmayer from the Ocean Science Trust.
Great, thank you so much. I do not have slides, so I'll just share a bit conversationally with you all, and thank you all so much for having me. I'm Lauren Linsmayer with the California Ocean Science Trust, or OST, and my role is called Senior Science Officer, which is essentially like a program manager. So my organization, for those who don't know, we are what's considered a boundary spanning organization. We span the science and the policy and management realms in the state of California. So we're a 501c3 nonprofit that was created 25 years ago in state law to formally bridge the gap between ocean and coastal science and sound ocean management. And what that means on a day-to-day basis is that we are working a lot with both scientists in the state and beyond, and the management and policy communities, both within state agencies as well as the legislature, to help elevate science issues and translate and synthesize science for decision making. And how I got into this role is my background is in marine science. I started pursuing a research career. I received a PhD in marine biology, and pretty quickly in that experience, realized I wanted to sort of broaden beyond research and into making research have a broader impact on society. So I did a fellowship in Washington, D.C. right after that really turned me onto policy and opened a lot of doors, which was the Knaus Fellowship through NOAA. There are a lot of other great science policy fellowships out there I like to point folks to. And that also helped me realize that I wanted to be more of an expert generalist than just an expert in my career, and have really stayed in a broad, high-level space since working for Congress and then working at various small nonprofits. So typically, my organization is fully remote. So I'm on Zoom a lot, which can feel like a bit of a downside, but each day is quite different and dynamic. We're all, as program staff, managing and working on various projects at once, 2 to 4 projects. So a lot of time management is needed, but that part is, I think, very exciting about the work, getting, to work right now on topics as diverse as fisheries insurance to marine carbon dioxide removal. And then there is occasional travel to places like Sacramento or along the coastline for convenings like workshops and meetings and forums that we host to bring together the management and policy and science communities to, discuss these issues. And then, yeah, the different skill sets we use most in our job are science communication and synthesis. So that is both through, writing reports that might be summarizing the state of the science of a topic and putting it into a policy context. Some of those reports can be on the longer end, but we also try to write a lot of shorter summary documents that are more fit for decision makers to consume. There's a ton of relationship and partnership building in our work. That's something that I really enjoy and see as a huge advantage of just getting to know a lot of people in the landscape and helping elevate their work and build long-term relationships with them. And then also there's a lot of listening and asking figuring out what questions to ask I'd say a skill I'd like to really highlight that was a big transition for me coming from academia into this type of work is, figuring out which level of detail to stay at as opposed to getting very caught in the weeds, which I do love to do, but often there's not enough time to become an expert on everything. So figuring out how much do I need to know and knowing who the experts are that I can call upon to get those details if needed. And then, yeah, in addition to all of those fun aspects of the work and just being a really dynamic, constantly changing, policy landscape that we're navigating, and also having it be very exciting, getting to stay up to date on the latest science. Certainly there are some challenges of the work, like not everyone really knows about or understands the value of boundary spanning organizations like ours. So just getting the word out about what we do and why it matters. And then also different value systems and timelines in academia/research and policy. Policy can move very quickly, and research, has its own time scale it's working on, and often it's hard to get those to align. And so just some advice for early career scientists is hopefully you're learning more about all of these different sectors, and that if you're someone like me and don't have a certain topic you want to settle on or choose for the rest of your career, you don't have to. You can work at the intersection of a lot of issues, and that it's really valuable to figure out how to communicate the value of your degree versus your specific knowledge base, which might change depending on your job. But these big skill sets that we've been talking about, like translating your research into skill sets like project management, science communication, figuring out what these skill sets are needed in the jobs or sectors that you're interested in. So I'll stop there. Thank you.
Thank you so much. Wonderful. Emily, you should be able to share your video and unmute now. Welcome.
Hi, everyone. You able to hear me?
Yep.
Great. Thanks so much for having me. I am an associate professor of chemistry, actually, at California Polytechnic State University in San Luis Obispo. And Cal Poly is obviously a state university, part of the CSU system, and quite a big institution, but our emphasis is on education. And for me, Cal Poly is this sort of sweet spot between teaching and research. So really the primary role of my job is teaching, but Cal Poly places a really large emphasis on research and having their faculty be productive researchers in addition to their teaching role. And for me, that's kind of this perfect blend where I get to teach research as well as teaching in the classroom. And then Cal Poly is this wonderful place because we have a pretty strong marine program, and we have a pier and access to a lot of marine resources. How I got here is I went to a PUI as an undergrad and really valued that experience. Like that's really how I became a researcher, was that I got into the lab when I was young. And so I saw teaching as a way to kind of, I don't know, pass that experience along to others. I essentially sort of did a teaching postdoc after getting my PhD. That isn't really what it was called. I took a visiting assistant professorship position, but I did that instead of a research postdoc. And so that's sort of what it was for me. I got my feet wet and did those first couple of years of teaching. A lot of classroom hours are really hard. And so it was a way for me to learn and sort of a training experience for me before I came into this role, where then I went back to sort of balancing teaching and research. How do I spend my time? What my job looks like these days is, I like to say about 50% teaching and 50% research, but that probably underestimates the teaching. It depends on the quarter how much I teach. Right now, I think I'm in the classroom 12 hours a week, which is a lot. And if you don't love teaching, then a PUI probably is not in your future. But then I also teach my research group. So I run a research lab that is composed of like anywhere from 9 to 12 undergraduate students. I sometimes sit on a master's committee, but I don't directly advise master's students. And so we do a lot of research, and part of my love and goals are primary scientific discovery, right? Furthering scientific knowledge is still a goal that I have, but that's layered along with teaching future undergrads how to be scientists, right? And so part of my training of those students is really not about research, right? It's about training them to do research. And it makes for really interesting brainstorming and interesting thoughts about what science can I accomplish in an efficient way with students, where they get to be parts of the discovery, right? And not just cogs in a machine, like where they get to really participate and get their hands dirty. And how do I do that realistically, right? With realistic science questions. And so for me, yeah, I get sort of like the best of those both worlds. I am now, as I, have gotten tenure and I moved on to an associate position, I'm also taking on more leadership roles, both within Cal Poly and within like the broader scientific community. And so that's still a part of my career journey and something that I'm finding a lot of reward from, or that I'm really enjoying. And so I think sort of the advice I would give is that like every path has flexibility, right, to make it your own. And there's obviously boundaries on that. Like I still need to teach some number of classes every quarter, or it'll be semester soon. But you do get to sort of choose your own adventure and make a job in academia, at least a place like this, sort of work for you within the bounds. But it's busy. There's too many draws on my time. There's too many things I want to do, and learning to say no, I think is like constant theme in my life and in many others. So I think I'll stop there, but I can always answer questions later.
Thanks, Emily.
Mm-hmm.
Okay, who's next? Jochen,
Very good
please
try.
correct me.
It's difficult. I was waiting for that. Okay, so I don't have slides specifically for this event, but I did a career panel a couple of years ago, so I'm just going to pop them up in the background while I kind of touch on the questions you've kind of shared with us. Let me see, how do I share here? Obviously, this is not related to today at all, or it's at least a little bit outdated, but I'm Jochen Klinke. I'm a director of science at Siebert Scientific, actually. So I work in industry, unlike most of what we've heard so far. My role is really being the voice of customers. That's you as a researcher, within Siebert. It's primarily I'm trying to understand what problems you're trying to solve and how we can support that, whether that's through new technology development, methods in measurement, sensors, or just data analysis. So it's really, for me, very cool and challenging to support somebody else's science. So I'm not doing science myself, but my role is to support other people's science. My background is in science, applied physics to be correct. I focused a lot on lab and field measurement and sensor development, first in academia, as you can see there from the slide, then as part of a small startup, and later on at Siebert Scientific. Unlike what I've heard so far, my day varies so much, I can't give you really a typical day. Involves traveling, involves interfacing with customers, occasionally some field work, a lot of computer work, a lot of ping on Teams calls. So, but it varies so much that I couldn't really give you a daily routine. I think one thing I want to focus on is really the skill sets that kind of have helped me be successful in my current role. That's mostly problem solving. And I don't have really formal training in problem solving, but coming from science, you do it on a daily basis. And I think what's new to me at Siebert is that there's actually a framework around it that really kind of establishes kind of the guidelines for how you're supposed to go about that in a really efficient manner. And that really helps if you have to interface within different functions in the organization or with customers, with external stakeholders. So that's really helpful to understand how do we approach this in the first place. And so I think that's the thing I probably do most of, is just solve problems every day. what I really love is that I get to work with people who are really passionate about their work. The feeling of kind of making a difference is really rewarding. The biggest challenge is really being open to learning, and that doesn't just include hard skills like learning a new programming language like Python or something, but a lot of it is really around soft skills, really your ability to engage with others, that being able to listen well, giving and receiving feedback, something I really continuously, it's really a path for me, you know, in terms of getting better at that. If I had any advice for early career scientists, since I've been making that transition a long time ago, I kind of interviewed a few people at CBER that are early career scientists, if they have any recommendations. I mean, from my end, it would be really being just embrace ambiguity, being okay with not knowing what's coming and being kind of leaving your comfort zone a little bit. As long as you're open to learning, it's okay. On the other hand, the kind of more tangible advice from people were consider internships earlier in your career because it may inform how you want to structure your course load. Like I said, being open to learning is key. And I think some people think of having very specialized skills as an advantage. Actually, I think having a very broad skill set in my mind is much better. It's a good basis for transferring your skills to certain applications or roles. So if you think about that, don't be scared to kind of broaden your horizon a bit. And I think that kind of sums it up from my end.
Thank
Be
you
happy to
for
answer questions later too, especially if it relates to industry and how you get connections there.
what a fantastic visuals too. I'm inspired.
Be happy to share them if that's of value.
Why don't we go to Regina, joining us from National Institute of Standards and Technology.
I don't have slides, but I'm really happy to be here with you. I am currently a research chemist at the National Institute of Standards and Technology. I am housed at the within the material measurement lab and in the chemical sciences division, where I work on standardizing pH buffers. That's like my primary role here. And so being here at NIST, we have a lab space that we manage. And so in terms of day-to-day operations, I would say that, while I'm not conducting experiments every day, that still is very integral to my job here. I no longer am able to do field work. I came here with a degree in chemical oceanography, studying ocean acidification, like doing carbon system measurements as one of my primary outputs for my dissertation. And the reason that I was interested in a place like NIST is because at the time they had a postdoc opportunity to look at the traceability of ocean carbon measurements. So being here at the National Metrology Lab, we think a lot about not only the traceability of measurements to the international system of units, but also to uncertainties in the measurements that we're making. So we certify a lot of different chemical and biological standards. So I do work on the pH buffers, but another area of focus is looking at, for example, chloride in human serum. So I think a lot of us, we kind of specialize in different measurement techniques. So as a postdoc, I transitioned over into focusing less on oceanography, but definitely more on general standards. Since we are at a metrology institute, we also work with the broader metrology community, and I am a participant in one of the working groups at the International Bureau of Weights and Measures. And through that working group, we help to think about different types of measurement challenges, and a lot of that comes out of the organization of interlaboratory studies for the measurements that we use for these standardizations of our buffers, for example, or our coulometric methods that we use to standardize things like hydrochloric acid solutions. So those interlaboratory studies occur regularly so that we can confirm our ability to provide standardized products to all of our consumers. And typically, about once or twice a year, we have to participate in those activities as well. Additionally, I am fortunate that in my position, I also get to serve as an adjunct faculty member at Georgetown University, where I'm part of the environmental metrology and policy program, and I teach a course on environmental metrology. So students in that course, they get to think about the linkages between the type of science that we do at a place like NIST and environmental measurements that people are doing in the field. And let me see. In terms of skill sets, I think one thing that was really helpful is just being adaptable in terms of being able to transition the skills that I used while I was studying ocean acidification into electrochemical measurements that are done here at NIST. A lot of the techniques that we use here, especially for working on the primary pH system, they're very unique. I don't think there are many labs in the world that have Harnett cell systems. And so there was a lot of time initially when I came here that was spent on training on the primary pH measurements. So we learn a lot about these primary measurements that aren't really widely used, but they're really useful because they have low uncertainties and uncertainties that are well characterized. Um, so just being adaptive to different types of measurement services that might be needed is really important. And also delving into programming. I know a couple of other panelists have mentioned that as well. So initially, I know I was trained in MATLAB programming, but since I've been here, I have taken courses that were given by, for example, our statisticians that work here in R and Python. And those I would say are probably the primary tools that we use now to integrate our data collection and also our data processing. And what I love about this role is that I do get to balance being in the lab. And as I stated, I do have opportunities to teach as well. So that is really enjoyable and rewarding to me. And in terms of advice for early career scientists, I would say it's really great to get involved, especially on different types of working groups. I'm really fortunate to have been involved with one of the SCORE working groups that Heather has been a part of. And so that has helped me to stay connected to the ocean sciences community and to really help to use the resources that we have here to try to elevate some of the science that is being done by researchers that work in the field. So thank you.
Thank you, Regina. It's always so much fun to work with you. So that's why I reached out to ask you to be on the panel. So thanks so much. Let's go to Tyler from Carbon Plan. Welcome,
Evan.
Tyler.
Thank you. My name is Tyler Kukla. I'm a research scientist at Carbon Plan. We're a nonprofit, and what we do is, at the broadest level, help people do more of the stuff that works and less of the stuff that doesn't when it comes to climate solutions. And I can talk a lot about what it's like to be a nonprofit scientist. I think that I have a lot of leeway and academic freedom in this role, which is surprising to a lot of people. The way that I kind of think about this position as a research scientist at a nonprofit is sort of like a supercharged postdoc without the publish or perish burden that kind of overwhelms a lot of researchers in an academic setting. It's really great to be able to, if I think that there's something that needs to be said, to be able to do that outside of the formal avenue of academic publications. We have blog posts, we respond to requests for comment from governments. We build tools and help people use those tools to make their work better, and a whole host of other things along the way. And just being able to have this wide range of impact and have that wide range of impact valued by your organization, I found to be really emboldening in the nonprofit research space. Also, that is a lot of the skills that I had to learn on the job, like how to communicate in a nonprofit research space and how to scope projects when we're working in a really applied sense. I come from just kind of a basic research geochemistry background. And maybe one quick bit of advice for anybody who's also coming from a less applied background, but hoping to pivot into a more applied space. In the world of carbon removal, which is where I spend most of my time, There is a lot to read and a lot to get yourself steeped in that world. There are a wonderful set of postdocs, some Substacks to follow. All of this is a really great way just to get started and being able to kind of talk the talk and walk the walk as you're going through and meeting people and going through interviews. Don't be afraid to send out cold emails, and especially to me, I'm happy to chat more if there's any way that I can be helpful.
Thanks, Tyler. If you have any specific things that people should follow, threads or resources, please feel free to drop them.
Will do. Thanks. Yeah.
Thank you. Sophie.
Hello,
Welcome.
everybody. Anyways, I'm the principal oceanographer and director of monitoring, reporting, and verification at Captura. We're a marine carbon dioxide removal startup company based in Pasadena, California. Before coming to Captura, I was a research scientist at University of Washington and NOAA's Pacific Marine Environmental Lab in Seattle. And then before that, I got my undergrad in chemical engineering and my PhD from the MIT Hui joint program. I think the main, what I do for my job is I have a lot of meetings. I coordinate, all of the partnerships that we have with different groups that we're working with. Basically, I'm the only oceanographer at Captura, and I have my background, which is in very similar to Regina's, which is in carbonate chemistry. I worked on ocean acidification and development of ocean carbon sensors. And then, so I have no modeling background whatsoever, but modeling is really important to quantify how much CO2 is actually being drawn down from our technology. And so I work with modeling groups. I work with other groups that also make observations. We do a lot of studies on looking at the biological impacts of our technology on the ocean, and work with an aquaculture group to do that work. Basically, I'm a coordinator of research projects, working with other groups that are more sort of experts in those different positions. Or projects. My main thing that I wanted to say, and I think I forget how you say your name, Jochen? He brought up that soft skills are really important in industry jobs, and I think that I wanted to just repeat that. And also, soft skills are really important. Being flexible, like Regina said earlier, in a startup, things change very quickly. And so being flexible, able to adapt to every situation. I think a lot of people that go into oceanography, you end up doing field work at some point, you develop those skills. Being resourceful, in the middle, when you're stuck in the middle of the ocean, you don't have the thing that you need. You need to come up with a way to get the work done still. And then something else I wanted to say was that try to fight imposter syndrome as much as possible. When I came into the job, I was like, wow, like I'm making all these decisions. Like, you're not going to check with somebody like after I tell you what I think. And it took me a while to build up the confidence. Like, actually, I do know a lot of things, and about oceanography. Having a young child in a startup position is very difficult and demanding. So difficult. What was I saying? Flexible. No, I was on to the next one. Don't be a perfectionist. Oh no, you know a lot of things. And the thing is, after you leave academia, you don't need to know things to like the 99.9% certainty. You can know them like 80% and you can still make the right decision. It's not going to change where you go. Okay, hold on. Give me 5 minutes. Okay, forget it. That's all. Let me know if you have any questions.
Thank you so much, Sophie. And extra applause coming your way for balancing. That's something. She brings up a really good point, actually, with the the need to get everything. We're so used to working in a space in academia where, you know, you need to get the highest precision, you need to get the most accurate, you need to get, you know, reduce your uncertainty as much as possible. And we're always striving for perfection. And I think that when you're in a more applied space, things move faster. And so, you know, as we shift from an academic to another space, there's this need to kind of adjust our timelines and our needs for perfection, or the level of perfection that's needed. So I think that that was actually really great insight from Sophie. Okay. Stephanie, welcome.
Hi, and yeah, great job, Sophie. That I can only imagine how hard it is to juggle everything while also trying to talk about your career path. I'm Stephanie Wilson, and I'm at the Smithsonian Environmental Research Center, which is one of the Smithsonian's research institutes. It's a little bit different than a university because we have no academic program. So my only interaction with students is with external collaborations or in the form of interns. So we have federal funded PIs that are long-term employees. We also have soft money scientists and postdocs and technicians, as well as interns. So I'm in the postdoc scenario right now, hoping to transition into a soft money PI position soon. And I transitioned into this role directly from graduate school. I studied coastal biogeochemistry at the Virginia Institute of Marine Science, and I've always been interested in research and really excited about research. So that's why I was looking for a research-focused postdoc. And my typical day is different every day as well. There's a lot of writing, a lot of field work, lab work, a lot of days on Zoom all day as well, working on a large collaborative project. There's always a lot of Zoom and Teams meetings these days. And I'll just keep it pretty short because I know we only have a few minutes. I think major skill sets that I didn't realize that I was going to need are people management. And that's something I've really had to learn on the job. And I think the soft skills that we've mentioned today actually are really important in academia too, because everywhere that you're working with people and students and technicians, and that requires a lot of soft skills and understanding and effective communication, which is done in a lot of different ways. Advantages and disadvantages of my position are that I get to be fully focused on research, which is something that as a research scientist who's excited about doing that, it's a dream. Although I do miss teaching. I did get to do a little bit of teaching when I was in graduate school, and I do miss the excitement of students. So I think that's something that if I had the opportunity to move into a career or have some teaching, I would definitely do that. And I get that through mentorship of interns. And then my advice for early career scientists, I think, is to leverage your network and talk to as many people about their jobs and about their process as you can and get their different opinions, because I think often when you're starting out, you have a few key mentors, but there's a lot of people in our community that are willing to help, especially on this call. I see some people in the audience that have helped me specifically. And something my advisor, Iris Anderson, said to me that I have always held close is make sure you're having fun, because if you're not having fun, it might not be worth it. So that's, I'm happy to answer questions about CERC or my role, but I'll leave it to the last person because I think we have one more.
Thank you. And that sounds exactly like something Iris would have said. Amazing, amazing woman. Okay, our last panelist is Riley Brady from Apple Weather.
Awesome. Hi, everybody. I am Riley Brady. I am currently at Apple Weather, as Heather shared. I'll kind of work up to that point, but I come from the oceanography community too. I did my bachelor's at the University of South Carolina in physical oceanography, and then did my PhD at CU Boulder with Nikki Lewandowski in ocean biogeochemistry. So throughout that decade, I was working on coastal upwelling systems, kind of went from physics to BGC, but I think the common thread throughout was I was really stoked about the programming side. I started with MATLAB for a couple of years and then spent all of grad school working in Python, and was excited kind of about all different problems, but just really enjoyed working with global climate models, regional models, ran simulations, got excited about making Python run fast on these simulations and just like making visualizations. And when time came to finish up my PhD in late 2020, I kind of took the dive into the private sector because I really wanted to try out this like data scientist, software engineering thing that I was so excited about. And right when I was leaving the PhD, McKinsey & Company in Denver, the big consulting firm, was building out their climate risk team. And it blew my mind at the time, but the job listing was like, we want a climate PhD that knows like Python, Xarray, Dask, and it was such an encapsulation of what I had been doing with my work with GCMs. And so worked there for 4 years and helped build the climate risk team there. So we were doing like heat wave assessments and drought and global flooding for companies in the UN, and trying to understand how their climate risk was booked over the next 30 to 50 years. And I started as a data scientist there and then spent 3 years doing data engineering and learned how to do proper engineering in the private sector. And then this January moved over to Apple in Boulder, and I'm on the weather forecasting team. So now whenever you open the weather app, my job is to make sure it's productional, operational, and I'm constantly trying to improve accuracy. So doing all the data pipelining for weather models and weather forecasting. Day to day is surprisingly similar to my time in academia. I spent a lot of my time checking out papers, writing code, doing exploratory viz. And then the difference now is once we consolidate down to a solution, it's a lot of like engineering it into a like robust, optimized, reliable system. Lots of cloud computing now on AWS. And so those skill sets that really helped me in this like software engineering sort of hard technical track was knowing Python and the Pangeo stack and knowing how to work with Xarray and Dask, especially working with climate models. But it's been hammered down here, but I'm a big believer in the soft skills from academia. So being able to be going from Ocean BGC to spending time working on heat wave modeling, being able to be told, go forecast like heat waves or wet bulb globe temperature, whatever it is, and being able to go to the literature in a day or two and get a good sense of like what the best practices in modeling are, and then implement it. And it's the same thing with working with weather forecasting too. Things I learned on the job, I think the private sector invests a lot more in teaching you on the job. You don't need to show up knowing how to use AWS and do hardcore engineering. So over the past 5 years, I've really learned sort of data pipelining and good software engineering practices. And I'm a big fan of the private sector. I've really enjoyed it. I think it's given me a lot of variable work, which I craved in academia, was these like shorter, more rapid projects with greater variability. I've really enjoyed the collaborative ecosystem. I find that in academia, it can be collaborative, but there's an underlying sense of competition for financial resources and getting a paper out on a topic without being declined because it's already out there. Whereas my private sector teams have been a lot of ex-academics who we get to just collaborate and build something together, fully together without reservation, which is super nice. And it's really visible. You know, I was doing a lot of theoretical work in academia that I do miss, but working with Apple Weather now, you know, I push something out and it's on these apps that serve a couple billion people, which has been really cool. Challenges, non-technical leadership is really hard to work with. People at McKinsey thought climate models were Excel spreadsheets, so they'd asked me to rerun a climate model, and it was immensely frustrating all the time. There's different interests from business leadership and big tech leadership. Timelines can be fast. You got to learn how to do 80-20 and get most of the way there, and can't go as rigorous and deep. You don't get to take your work with you when you leave places. So I spent 4 years at McKinsey building out a statistical downscaling algorithm for CMIP6 and patented it, and then left, and I can never touch it again. And it was a big passion project that I don't get to bring along. And I really miss conferences like this and people from academia, just a completely different community to be in. very quick advice to close out. There's more career paths than just data scientist. I'm super eager to get people into technical product management. I think scientists would do a phenomenal job there. I can talk more about that privately. I know we're running out of time. Scientific leadership, consulting, and widen your aperture. I'm an oceanographer and ocean biogeochemist, and I went into terrestrial climate risk. I was interviewing at companies doing forest carbon capture, and I'm now at a weather forecasting company. Your ability to do earth science at all, observationally or with modeling, exposes you to forestry, geospatial GIS, oceanography, atmospheric science, sort of a wide array of companies. And again, like soft skills are key to your marketing. You can learn a lot very quickly, very rapidly. Don't be scared away from job listings that seem like they have all these skills that you don't have yet, because they expect to teach them to you while you're working there. So yeah, feel free to reach out to me on LinkedIn. I'm pretty easy to find. I think my LinkedIn tag is just Riley Brady. I take a couple calls a week with early career scientists and people trying to transition out. So you can always message me there, and we can chat, especially about this like software engineering, sort of more coding heavy side of the private sector.
Thank you beyond measure for all of those fantastic insights that you provided. I really, really appreciate this panel. I'm gonna leave it open for questions for just a few minutes. This is gonna put us about 10 minutes behind, but I think it's worth it if people have questions. And maybe we can, are you all on LinkedIn? Maybe we could put an assembly of profiles together or email addresses so people can reach out and ask questions also if they think of things later. In the meantime, I'd like to open the floor for anybody who has questions. Either put them in the chat or raise your hand and you can unmute and ask them.
There's a chat question. Can you give some advice on getting internships in the private sector?
I'm happy to jump in there. I found it a little harder from our so I view earth science and climate science, and especially oceanography, to be really young in the private sector. Other fields like chemical engineering have long had a pathway to the private sector. So I don't find the internship pipelines as like robust as I'd like them to be. You'll see at the big consulting firms and big tech companies that they have generic internships, but that won't feed you into their weather and climate teams from what I've seen. So I tend to think any technical internship is good at this kind of companies if you're trying to go more like data scientist, software engineering. But I would advise you to find companies that really excite you. There's a ton of really good climate job boards out there. I've posted about it on LinkedIn, and cold message people and reach out to see if you can do any sort of internship. So there's a lot of startups that can use interns. My friend just started with Brightband, who's doing really cool AI weather forecasting, and it was kind of like they built it together. It's a couple months and he's doing product work. I think a lot of these small companies are willing to receive your excitement and potentially build internships out of there, but there's not a lot of traditional routes for climate and oceanography internships from what I've seen.
Maybe to add on what Riley said is at Seabird, we have a lot of interns on a regular basis. We actually work with a couple of universities, Oregon State and Scripps, to kind of offer internships. Depends a little bit on what you're interested in. It can, entry points can vary, or support, R&D, science, could be operations too, if you're interested in that kind of stuff, It's not really limited to purely scientific things, but I think product management, like you mentioned, is a great way to do an internship, because you get exposed to every aspect of a sensor, instrument, or product, So really cool way to start.
So thank you for the insights, first of all, to my question. So for both of you, it was great insights. And as you said, as Riley brought out, it was really difficult. I have been searching for sort of internships in the climate, weathers, atmospheric science, ocean, and or sort of applied ML and machine learning in the ocean or environmental science domain, and it's difficult. So that's the reason. It was a good insight, and I was wondering that how I can get I'm not interested in doing a pure machine learning kind of or pure data science kind of internship. My passion lies in applying those kind of techniques in the field of atmosphere and ocean sciences. So those kind of stuff if there are like, I would request that the OCB or this kind of bodies, if they can have a sort of database or something like that. I think that it cannot be started in a day, but some thoughts can be given towards that to make a kind of database of companies or in the newsletters, give this thing also a certain priority. That would be my request. Thank you.
Thank you. That's a great suggestion. Most of our early career opportunities tend to be very, fellowship or academic path focused. So maybe broadening that out a bit would be advantageous. There's a great question in the chat here from Emily regarding non-academic job postings. If you don't have some or many of the skills listed, how can you make the case in a short cover letter that you could learn or develop them quickly given your PhD or other academic training and experience?
Maybe I can comment a bit on that because we get that question a lot. I think one thing to remember is that you're not submitting a CV, you're submitting a resume, which is really geared and tailored toward a specific role that's being sought to be filled. So I think anybody in science has a lot of transferable skills in terms of problem solving, in terms of interacting with others. So I think even if not everything is perfectly matching, apply anyway. It's just you can kind of get a better feel in the interview process in terms of if this is something where you really have shortcomings, like a specific skill that's required but you don't have. So, but in general, I think rather we're trying to write our job applications these days, or job positions, in a way where it's more generic, because we want a broad spectrum of applicants.
Oh, go ahead.
I was going to just add to Emily's question. This goes along with the sort of like imposter syndrome thing. Like, you can put so many more things on your resume than you'd think. Like, writing papers, that's a big thing, but that involves, I'm sorry, my brain is like frazzled, but like, don't underestimate yourself in your resume. Like, you did a lot of things in your PhD or in your fieldwork. Make sure you go through and quantify those with numbers. How many days you were at sea, that or whatever, how many papers you reviewed, things like that, how much money you've gotten in grants, all of those things. I think also, like, I feel like when I interview people, I'm really looking at passion first and like culture fit to the company. And then, the technical skills, like, for the most part, you can learn on the job. I wouldn't hire somebody like that has no background whatsoever, but for the most part, if you have the will, there is a way.
That's great advice. Don't take yourselves for granted. All of the skills that you acquire just to complete a dissertation, right? Just to get through a day of graduate school. Think about all of the additional skills you acquire in programming or what have you, sensor design, anything, just to get, the means to the end, right? Really, really sit and think about that, and look up resources for transforming a CV to a resume if you're looking to make that jump from an academic position to a position outside. I think that's good advice. All right, well, it's 3 o'clock and we're 15 minutes past, and I'm fine to stay a little bit later, but I want to move on to our early career presentation. So I want to first give another round of applause to our amazing panelists. This was so much fun to get to know all of you just a little bit more than I already did, but to just hear all of your great advice and insights and experiences. So big round of applause coming your way. Yeah, please, if you want people to contact you, feel free to put your contact info in the chat, or your LinkedIn, or whatever way you want people to get in touch. And thank you again. Now you're going to meet one of our, actually, I'd also like us to Kristen Crumhard, you are here now, and I would love for Kristen and Melissa were not on this morning because it was some ridiculous hour where they are. So I just wanted to invite them to come on and introduce themselves. And then Melissa and Keisha are going to kick off a really cool and fun early career presentation and activity about crafting a compelling narrative about the science that you do, about who you are. So, is Kristen Crumhard on? Yes, Kristen, why don't you come online and introduce yourself? Kristen is one of our SSC members and co-chair of the Rapidly Changing Systems session. We'll start with you and then we'll have Melissa and then we'll move right into the early career activity.
All right, thank you, Heather. And so sorry for the mix-up this morning. I had it all wrong on my time. And
don't worry about it. We're all here now.
Okay, anyway, thank you so much. So yes, I'm Kristen Crumhard. I'm on the Scientific Steering Committee of OCB, and I'm a biological oceanographer at the National Center for Atmospheric Research in Boulder, Colorado. My research mainly focuses on phytoplankton and zooplankton and how they respond to changing climate and variability in climate and ocean conditions. I have a number of just recent projects. I'm balancing a number of projects at all moments, including looking at the emergence of signals in climate change in Antarctic ecosystems from phytoplankton all the way up through penguins. Also, I've been working with Alaskan and indigenous communities as well recently, looking how their marine ecosystem is changing. So that's been really exciting. And there's Jerry Ivanhoff's going to give a talk later on Friday, and he's one of my collaborators from that project. And then I'm also working with some national marine sanctuaries, bringing ocean climate data to them in a useful way so they can better manage their ecosystems. And in addition to being a scientist, I'm also an artist. So I love to draw everything that I study, and the science is really my artistic inspiration. So I guess that's me in a nutshell. Thanks so much, Heather, for giving me an opportunity to introduce myself after I missed it this morning.
You're so welcome. And I want to point out that Kristen is an amazingly talented artist. And so she designed the Rapidly Changing Systems schematic that you saw on the workshop website. And she also designed one of the t-shirts. We had 2 winning t-shirt designs last year for OCB. I'm wearing one of them. And then tomorrow I'm going to wear Kristen's. Well, I have one of each. And both fantastic designs, but very, very, very talented. So
thank you.
All right, Melissa, it's your turn to take it away, and let's bring Keisha on too to join you, and you can both introduce yourself.
Thank you, Heather. I'm sorry I missed this morning too. I had a messed up with my calendar. But so happy to join. I joined a little bit later, like an hour later, so I was able to take most of the meeting. And it's great to, have the beginning of this meeting with the early career focus. So thank you, Heather and May, for all of the support for this community. I'm a scientific steering committee member, this early career representative. So I also a research professor at the University of Hawaii at Manoa. And I mostly work with biogeochemical cycles, especially the carbon chemistry, ocean acidification in different coastal systems. I also work with ocean alkalinity enhancement and recently how this ocean alkalinity enhancement affect different ecosystems like coral reefs. So today, and that's how I met Keisha Bahr, one of my co-PIs and great collaborator. So I invite her today for this section because she's a co-author of a great book. It is called The Narrative Gem, and we will be discussing that book today. So I'm just gonna pass to Keisha so she can introduce herself and then we can start.
Awesome. Thank you, Melissa. Also, good morning or afternoon, everyone. Thank you so much. This is my first time at an OCB meeting, and it has been amazing. Like the amount of support and like how like collaborative and communicative the audience or everyone is so amazing. So thank you so much for welcoming me into your community. I am an associate professor in marine biology. The work that I do is primarily focused on how calcifying organisms respond to environmental change. So like Melissa said, I do a lot of work with corals, and we have a grant right now looking at how ocean alkalinity enhancement impacts corals and coral reefs. So I'm more of a biologist, a benthic ecologist really, but it's really great to hear similar veins of what's going on and understand the chemical side of the biological side that I'm investigating. So today, Melissa and I were talking a little bit, and I just want to make sure you guys can see my screens, correct? Yeah. Okay, good, thanks. We wanted to talk a little bit more about communication, and I think it lined up really well regarding the early career panel and some of the things that folks are looking for regarding these soft skills or how to transition from academia into a position. And one of the things that was mentioned quite often was science communication, or be able to communicate with other people outside of your own inner circle or inner group. So this is something that I have been working on for the past, I feel like decade of my life, trying to understand how to become a better communicator. I've studied coral reefs for almost a decade and a half now. And while studying coral reefs, like most of us here, I have been very fortunate to work in some beautiful places, but I've also been very unfortunate in being able to see some of these reefs completely die right in front of my eyes. And when I was training as a graduate student, I thought that if I do science, I can change and help these corals regarding the decline that I was seeing. So I would go around and I would present information, have these images of before and after of coral reefs dying and trying to talk to people. And then I would publish my work. And I found that regardless of what I did, corals were bleaching over and over every year. So to me, I felt like as a graduate student and a training scientist, that I wasn't being a good communicator. Maybe something was wrong with how I was communicating my science. So the first thing I did, of course, was I Googled how to become a better science communicator and try to find some more literature or information of how to be better at presenting information. And as you can imagine, and what you've probably been told, is if you know your audience, well, the most important thing is to know your audience, avoid any jargon that you give, and then also be relatable. So I try to stumble through graduate school and my science training using this unstructured way and these like 10 effective ways to be an effective communicator, but it really didn't seem like it was working well for me, or I didn't really feel like I actually got what was going on with communication. So what we wanted to focus on for today is kind of this pathway that I found regarding to have a little bit more structured way of science communication. And this is actually during the pandemic where I met Dr. Randy Olson, who has done narrative training for, I think, 2 decades now, and has gladly accepted me into his team, or I call it a cult, regarding how we do narrative training and how we think about structuring pieces of information. So he's written plenty of books about narrative and how narrative is everything, or Houston, we have a narrative. And he has also published these narrative gems that Melissa mentioned earlier. So I took his course and I started working with him to really understand how to be better at communicating and also how to train students at being better at communicating. So I've been doing this communication training for about 6 years now. And about 2 years ago, we wrote the book on how to teach graduate students and postdocs about communication using the ABT framework, or the and, but, therefore framework. So what we're going to do today is I'm just going to give you a short introduction about the ABT, just so you have an understanding of what it is, and give you some exercises that you're welcome to use. And we also have some exercises in a folder on the Google Drive for you as well. And I also have a PDF of the book as well, so that you don't have to buy it. It's like $4 on Amazon, but so you have that handy. And then after we do the lecture, the mini lecture on the ABT, which we typically do this over a semester-long period, but I kind of shortened it. Then we're going to step into the second part of this exercise, is building a one-pager using your ABT or your narrative to communicate your research to a funding agency or an audience of your choice. So I just want to give you a preview of what the rest of this hour is going to look like. So first, I just want to start out by saying, I think all of us are really aware why science needs story, or why science needs some information regarding, or some structure about how we present information. Everyone is very distracted, and just giving information in an unstructured way is not effective for capturing your audience or communicating with people. Also, as some of you may be familiar, is as soon as you go and talk to anyone or try to network or communicate, the first thing people usually ask you is, what exactly do you do? And most of the time, we feel really overwhelmed because we want to share a whole bunch of information with that person, but we don't know how to share it in a way that's effective and constructive for them to receive it. So this could be a really effective way for putting all that together and also lessening your anxieties about talking to people. So one thing I want to show you real quick, and this will take like just 2 minutes, is I want to show you how different people tell information. So this is an interview between Bill Gates and Steve Jobs, where they talk about how there are some Microsoft products integrated into an Apple computer. This is an interview that happened in 2007 or so. So I'm just going to play this, and hopefully I shared my audio too. So maybe let me know if you can't hear it.
Some people hear, but I don't think most people know that there was actually some Microsoft software in that Apple II computer. Do you want to talk about what happened there, how that occurred?
Yeah, there have been the Altair and a few other companies, actually about 24, that have done various machines, but the 77 group included the PET, TRS-80,
Commodore.
and the Commodore PET, TRS-80, and the Apple II. The original Apple II BASIC, the integer BASIC, we had nothing to do with, but then there was a floating point one where, and I mostly worked with Woz on that.
Okay, so you hear Bill start to provide some information about the answer to the interviewer's question, and then immediately Steve Jobs interjects and wants to tell the story. So please listen to the way that Bill told the information versus how Steve's going to tell the information. Oh, let me go back.
And I mostly worked with Woz on that.
The story. Okay, so Woz, my partner, we started out with this guy named Steve Wozniak, brilliant guy. He writes this basic that is like the best basic on the planet. It does stuff that no other basic's ever done. You don't have to run it to find your error messages. It finds them when you type it in and stuff. It's perfect in every way, except for one thing, which is it's just fixed point, right? It's not floating point. And so we're getting a lot of input that people want this basic to be floating point. And like we're begging Woz, please make this floating point.
Who's we? How many people are in Apple?
Well, me.
Yeah.
We're begging Woz to make this floating point, and he just never does it. And he wrote it by hand on paper. I mean, he didn't have an assembler or anything to write it with. It was all just written on paper. He'd type it in. He just never got around to making a floating point. Well, this is one of the mysteries of life. I don't know, but he never did. And so, Microsoft had this very popular, really good floating point basic that we ended up going to them and saying, help.
So you can see that they pretty much told the exact same information, but in a different structure of that information. Bill was just providing lists and lists of information or telling more about the software and how they integrated it. But Steve took this whole story and took you on a journey regarding what the problem, setting up the problem, what the problem was, and what the solution was from that. And they're saying exactly the same thing. We can understand what Steve is talking about, but I don't think any of us really understood what Bill was talking about because it wasn't structured in a way that we could receive it as an outsider of what they typically talk about as computer scientists. So this is where it becomes really important for how we communicate with each other. Us as scientists, we can talk to each other and not have to have a structure about how we structure that information. But when we talk to other people, the public or people outside of our expertise, we need to structure information that's easier for people to understand what we're saying. And this is where we have a difference between how we talked with our inner group versus our outer group. So today I'm not going to focus any on our inner group because we can all talk to each other just like this and not have to structure how we present this information, but we do have to structure information when we talk to our outer group or the public. So this comes from this story structure or this narrative structure that is a universal story structure that was popularized by Joseph Campbell. And if you want to learn more about this, I highly encourage it. But it starts out with having the structure of a monomyth, where you have a start, of the story that is setting it up regarding this ordinary world. So this is no problems. This is all the background information that the person needs to know in order to understand what the problem. Then we enter the problem. So this is where we start to see the narrative, where there is a search for the solution to the problem, which is considered our narrative structure. And then once you find the solution, then you go back into our ordinary world. So this is circular pattern of setup, problem, and solution, because us as human beings are very problem solution oriented. So we're providing information in that same way that is inherent in who we are as humans. So we call this narrative structure. We're moving away from just listing information, this and non-narrative form, to this and, but, therefore form, where you have a narrative introduced. You have setup, problem, solution, setup, problem, solution. But the problem with us academics is that we get overly narrative, where we start introducing more information. We say there's this thing happening, but it's not there yet, despite everything that we've done. However, we've also done this other thing yet that hasn't worked, blah, blah, blah. So we get really overly narrative. What we want to focus on is being right here in the middle of just an interesting level of narrative and not overly narrative how we talk with our outside group. So I just want to say that this is not new. This structure is very popular across different types of media. The New York Times uses this and, but, and therefore structure, where they have background information here. They have a but statement, which is the problem, and then they have their therefore statement. It's very popular in nursery rhymes. For example, Jack and Jill went up the hill to fetch a pail of water, but Jack fell down and broke his crown. Therefore, Jill came tumbling after, something like that. It's really popular in speeches. For example, this is paraphrasing the Gettysburg Address. We are a great and mighty nation, but now we are engaged in a horrible civil war. Therefore, it's up to us to make sure that those that were lost do not die in vain. TV shows, very popular with story structure. You'll see a setup, Walter White and his family. Walter White loves his family and would do anything for them, but he gets diagnosed with cancer. Therefore, he gets involved in the drug trade. Pop culture, this is one of my favorite references. We had this very popular song, Call Me Maybe. Maybe some of you remember this, even though it's like 13 years old now. Hey, I just met you and this is crazy, but here's my number, so call me maybe. So very formal, very popular way of setting up information and story structure. We also have a story structure or a setup structure in academia, our NRAB templates. And what I have taught my students in my courses that I teach here at Texas A&M in Corpus Christi is that we provide this setup in our introduction, our and, but, and therefore, so you can have a narrative there. Your methods and your results are very and, right? Because you're explaining how you did things and what the results are. And your discussion could go back to that and, but, and therefore format. So this has been a framework that we've been developing. We have a lot of different books from business to politics and medicine. And he just published another book regarding speeches and politics. So there's a lot of different ways that you can use this ABT, and it crosses all of our disciplines so we can better at communicate with each other. So I just briefly want to talk about what do I mean by this structure, because you can't just put and, but, and therefore in a sentence and say that there's a narrative structure behind that. So what we need to do is I want to walk you through a couple of examples, and then we'll have the rest of the time to focus on our one-pager and your own ABTs. So what we do with our ABT training is that you have all this information or this content here by these shapes on the left-hand side, and we provide structure to that content or how you present that content. So what's really great about what I do is I teach this class and I get to learn about what everyone is doing. I have no expertise in it at all, and all I help them with is structuring their narrative so that they become effective communicators. And that's pretty much what we can do here, where you have your research message here. So I just have a lot of random words regarding coral reefs and how they're in decline and all this information. And then what we do with the ABTs, we provide this structure behind it to create a story essentially with it. So that's what we're going to focus on for today. Now, the baseline of the ABT framework is this setup here, this and statement or this agreement, which is our non-narrative. And then our but is where we introduce the problem solution dynamic. And then therefore is our consequence or our solution. So you could have one sentence that has all of this in it, but you likely have 2 or 3 sentences that have and, but, and therefore in it. And it might sound like this is like a very simple way to just stick these 3 letters in the sentence, but it becomes a lot more complicated than that. So for example, when we look at the and, but, therefore statement, we have a lot of different levels that we can investigate at the same time regarding, are you talking about one narrative or do you have multiple narratives? How do you structure your information, introducing the if-then statement? What is our ordinary world and what's at stake? Why is it important? And how are you addressing the problem? So there's a lot more level of detail that we can go in here. But for today, this is just going to be a little teaser that you can read more through and also use the worksheet that I made that's provided in that folder too, if you want to go into more detail. So whenever we work on our and, but, and therefore, we always start in the middle, the problem, because the problem is the most important thing. And the problem is usually what your research question is or the research gap that you're trying to fill. So one of the most common things that I've heard about or that I see with my students is they have too many problems that they want to talk about at one time. So we want to make sure that you're just focusing on one singular problem. So for example, here's my ABT. It's very, very long, so I'll just paraphrase it. Climate change is putting stress on corals and we need to protect them for the future, but we don't know if MCDR techniques will impact corals. We don't have a historical record. We also have local impacts that are also a growing threat. Therefore, we are implementing several new projects to address all these problems. So what I tend to see with students is they want to throw all of these problems in here because these are all of the different things that they're investigating, or even us researchers too. But what we need to do is just focus on one singular problem here. We can't have all 3 of these things in the ABT because there has been evidence that shows that the public can only focus on one thing at a time. So if we introduce all of these, we need to make sure that there are 3 separate ABTs. So there are a variety of different activities that I use to help people get to the core singular narrative of what their research question is or their problem is. One of my favorite ones that I like to do is the 3 forms of an ABT, where we have an informational ABT, which is not concise, but it's very compelling, has a whole bunch of information in it. A conversational ABT, which is very concise, but not compelling at all. And then from there, we can get our keeper ABT. So what I do with students is I first have them, most of the time their ABT is a conversational ABT like this one here. There's a lot of detail, too much information in it, don't really know what's going on. I actually flip it and have them provide a conversational ABT. And this helps us get to the core singular narrative of what their research question is or the problem that they want to talk about in their ABT. So the way that we set this up is they can't use any words that a 3-year-old doesn't know. So I have them say that they're talking about coral reefs, for example, in my ABT. There are these things and they're important. We need to take care of them, but we don't know how. Therefore, we need to figure out how. And if you distill and remove all of the information from your regular ABT, it's really helpful for you to really get at the core problem that you're trying to address. And then from there, you can fill in back the information and make it more detailed, and this helps you get to a keeper ABT. So my previous ABT, I had all these other problems, MCDR, not knowing genetics, influence of local stressors on corals. And based on my previous conversational ABT, I got to the single narrative is we don't know how ocean alkalinity enhancement affects coral reefs. And that can help us really get to the one thing that we want to talk about or the one thing that we want to communicate with that audience, or at least the first thing that we want to communicate with that audience. So after we have an idea of what our problem is, then we go to our setup. So we need to tell our audience or tell whoever we're talking to information about what we're going to introduce as a problem in order for them to care about our problem. This is set up in 2 different areas. The first part of the and is the what, and the second part of the and is the why does it matter. And the most important thing about this is you have to make it relatable. One of the most common things I've seen is many people start with bad news. They start with everything is dying and there's nothing we can do about it. And that doesn't allow for a common ground to be established with your audience. And actually, that contradiction actually closes them off. And we find that is one of the biggest ways that people lose attention of their audience. So the best way to start is with a common ground with the audience or make it more relatable to your audience. So usually what I suggest we do is we start with a simple description, something that a climate skeptic cannot argue with you about. Okay, so coral reefs are animals, or corals are animals, right? We know this, like this is what we know. We take this from the skit, the SNL skit, Dr. We Know This. So what do we know? Tell them why your thing is important, or what is it? And then you want to tell them why it is important. And this gives us more information about the power of specifics for storytelling, so people understand why they should care about your research that you're looking at. So you'll have here the what. Coral reefs are animals that build structures that you can see from space, and these structures provide services for millions of people and also support 25% of our marine life. Okay, it sounds very important. And then you introduce your problem, but they're dying, therefore we need to save them. So this becomes really important with what information you actually provide. So for example, one of the ABTs we've had before is I have 17 vacuum cleaners in my house, but one of them is broken. So setting up that you have a broken vacuum cleaner, that meaning that you have 17 or 16 other available, doesn't really seem like a problem. But if you only have one vacuum cleaner in your house and you have two very hairy and fluffy dogs like I do, and it's broken, then that becomes a real problem. Right? So providing that information in your setup is really important for your audience to know why your problem is important. So here, my ABT, going back to it, I start with bad news. Climate change is stressing coral reefs, and effective management and technology are key to their survival, but we need to understand OAE on corals. So instead, we want to switch this to make it a common ground, or something not as conflicting or not contradiction. So here I switched it to ocean alkalinity enhancement is a carbon dioxide removal strategy that reduces ocean acidity and can benefit coral reefs, which provide vital ecosystem services. But we don't know the impacts of OAE on coral reefs. Therefore, we're conducting research on it. This allows us to have a common ground to have a conversation with our audience, and it also changed the story to be about OAE instead of about coral reefs. So this becomes really important with aligning our narrative with our audience. And then our last part of the ABT is a therefore statement. This is actually one of the easiest parts of the ABT because this most of the time is what you're doing for your research. This is your consequence. But the thing that's really important and can make your ABT even more powerful is how you transition from the and to the but, and then the but to the therefore. Because what happens is as soon as you say but instead of however, I mean, however is softer, but as you say but, people are immediately alerted, like their brain activates. They've seen this with scans, MRIs of the brain, where they're excited when they hear the introduction of a problem. So introducing the but, the contradiction, it excites the brain, and your therefore soothes the brain. So we want to make that transition from the and to the but very rapid, and then also from the but to the therefore. And you might be wondering, how exactly do we do this? I have a good example for you. But we like to call this the transition with the but and the therefore 2 moments. The first one is introduction of the problem, and the second one is introduction of the solution. So the way I like to think about this is us as scientists over here, we like to introduce the methods first, the how first, and then the what, right? That's how we are in grade. We want to tell you how we did something, what our methods were, and then what the results were. But everyone else wants it the other way around. They want to know the result first, and then how you got to that result. So all we're doing is we need to switch that information so that the audience can understand you better and have get that result faster, soothe that brain faster. And this is really easy. So in the but statement, as a scientist over here, we would say, but OAE is a new field and the effects on coral reefs are poorly understood. All you need to do is switch things around and say, but the effects of OAE are unknown because it is so new. And it's just switching how you provide that information that can make more of an effect and catch the audience that you're talking to. We can do the same thing in the therefore statement. So on the left-hand side, as a scientist would say, therefore, we're conducting these experiments. We're looking at different minerals and alkalinity, yada, 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 to investigate the impacts of OAE on corals. Or if you're talking to the public or a broader audience, you can say, therefore, we're investigating it by doing these things. Because they want to know the answer first and then the details later. And that can be a really effective way to capture your audience and keep them engaged just by switching around how you present information to them. So one of the really good examples I like to show of this is one that Dr. Nancy Knowlton has given us for the ABT training, talking about how we've impacted our ocean. So here's her ABT. The ocean is important in many ways, and because it is so big, we didn't think we could hurt it. But we overfished, polluted, heated and acidified the ocean, and it's now dying. Therefore, we have to change our ways if we want the ocean to be healthy again. So it sounds like a pretty good ABT, but if we switch the but statement to the ocean is important in many ways, and it is so big, we didn't think we can hurt it, but it's dying because we overfished, we polluted, heated, and acidified its ocean. Therefore, we have to change our ways if we want the ocean to be healthy again. So just doing one small thing and switching where we present that information in the but statement, you can also do it in the therefore statement, you can make it more impactful. But the previous ABT is still really great, even though we just made that slight modification to make it more impactful. So this is just a short introduction to the ABT, so you have an understanding that it's not just putting and, but, and therefore into a sentence. This is a very effective tool that you can use, and I teach students on how to use it in a variety of different applications. So elevator pitches, you can have your and is your background, who you are. Your but is your purpose, what you want to do while you're in grad school, what you want to do next, and your therefore are your goals. So what happens after you're done with graduation? Or you can make it in the context of the work that you're doing. So your and theme is what are you doing? What are you researching? Your but is your question, and your therefore is your research and how to address that research question. You can also use it in conversations or presentations. I do this all the time with my presentations. I have and material that sets it up. The but is the problem, and then my therefore is the research that I do. And I usually have 3 ABTs in a presentation: set up, problem, solution, set up, problem, solution, to really help me structure my information and not make my presentation really convoluted and confusing. But it allows for a structure, and my audience understands that there is a structure because they're looking for that structure of information being presented to them. And of course, you can use this in abstracts, proposals, manuscripts. It's really effective for writing because you have your setup, you have your problem, you have your solution. Sometimes when I do writing, I just write sentences and then identify if this is a setup sentence, or this is background, or this is introduction of a problem, or if this is introduction of a solution, to align things and start building out from sentences to paragraphs to pages. So this is, like I said, this is just a very short overview of the ABT. There's also a lot more resources regarding this. All of you should have access to the PDF of the narrative gen. I think it's less than 90 pages. We didn't want to make it long on purpose because if it's too long, people don't read it. And it goes over in more detail what I just gave you, this information. Also, Randy Olson has a ABT Time podcast on YouTube where he talks about this and talks about everyday life and how it's structured in the ABTs. And don't worry about the survey. Sorry, this is left over from a class that I taught. But if you have more questions, please let me know because I'm happy to provide more information about it, because this is such a short period of time. I usually do like a 2-hour seminar on an ABT, and we work through individual ABTs to provide that structure. But we wanted to give you a taste of the ABT so that you had this as a tool and you could learn more about it and read more about it to have that in your toolkit. So now I'm going to switch it over to Melissa.
Thank you so much, Keisha. I should have actually talked to you before the congressional meeting last week. And thank you so much for agreeing to present this with me in a short notice. So as I mentioned, I was in the Carbon-to-Sea initiative convening last week or last 2 weeks. And one of the activities of the meeting was a Capitol Hill Day. And for that meeting, for that day, we had to kind of like talk with congressional staff, senators, and idea that I had from the department chair of my university, University of Hawaii, Margaret. She said, develop a one-pager where you have your ABT, basically. And I had a couple of recommendations from the meeting itself to how to present your message to the congressional people. And I just wanted to share that experience with you, especially early careers science. I didn't really know that. So we can go. Yeah. So basically, I'm just going to give you just 3 slides of my experience. You have 3 goals when you're going to meet with congressional people, which is one of the audience in the ABT framework. So you can have that audience, focus on that. And you basically can talk with them. You as an individual can talk with them, and you have 3 goals. Building personal relationship, where you're just gonna introduce the problem, talk with them, they know your name or where you work with. You can educate them. And this is basically like raising awareness of or providing information of a problem. Or you can talk to them to secure support. And that's a way of lobbying, and while providing information is not. So if you're going to ask for something, money, support of a law or anything, that's considering lobbying. And then you can go. So what I have recommendation was to the attention of the staff are very short. So you have to keep the meeting less than 30 minutes. And this actually talked about what Keisha was mentioned. You want to provide your message in a really concise way because they will start listening to you. You will have part of the protocol when you go to talk with them is that they usually have business cards, and they just put them in front of them so you know them. So I will recommend that all of early career students prepare the business cards. I put a example of mine that I built for this one. It's your name, your title, the university logo or the logo of your company or the logo of your lab, your email address, your phone number, your web page. And that way, that's something that you would leave the congressional staff with. And prepare your one-pager, which is basically, I will show it to you in the next one, but it's basically your ABT in a really nice way to like kind of leave that to them, because that's a way that they will remember you. Avoid jargon or any acronyms that Keisha mentioned. That's really important. They really don't know what you're talking about, and you have to spell everything. And a team coordination. If you're by yourself or if you're with a team, then you will have someone that kind of do the science briefing, another person that we actually ask for what, ask for the thing that you went through or your goal. And a thank you email should be actually sent within 24 hours. Sometimes the staff members will ask you for more information. They may ask you for any information from your university, your research, and you would just commit to send them a thank you note and the information that they asked within 24 hours. And this is my example of the one-pager. As I mentioned, I didn't talk with Keisha before this, but it was basically providing like high-level messages in a really impactful way, basically. And that page is printed in like kind of like a hard paper material, not in like a regular paper. And you have to put a picture. One of the recommendations that I had was to put a picture of yourself. And I thought that that was very weird because I didn't want to put a picture of myself. But that's a way for them to remember with who they talked. And a title, that's not the title of my lab or that's not the title of the university, but it was the title of the topic that I was talking about. And that way they will remember, oh, this person actually was talking to me about ocean alkalinity enhancement. This is the name of the person. This is the title. She works by the University of Hawaii, and this is her contact information. That's at the front page. Next, you will start introducing your problem or the introduction, the and that Keisha was talking about. Then you will provide the but, and then the therefore. at the end. And that will have a sequence to the end of the kind of the one pager, and you will choose about 1 to 3 pictures that actually represent your job. Recommendations that I had was like keep the font the same, have different colors in the stuff that you want to highlight, have only 3 to 4 key messages, which I will not have 2 ABT messages in one pager. I will have multiple pages for different ABTs, for example. And your one pager doesn't have to be focused on your congressional meeting or your policy audience. It can actually be built for any philanthropic organization or any other meeting, even for your ocean science meeting. If you want to have that with you, that's something that you can put in your poster or something that you want to leave the person so they remember you. And that's basically what I wanted to show you and help you build something like this. Even today, we may not have time, but Keisha and I are here just to help build this one pager or your ABT and a couple of ideas for a nice one pager. And with. So Keisha, if you want to provide the first, not sure how we are, if we are gonna have breakout groups or something like that.
Yeah, and I wanted to follow up because you kind of broke out there for me real quick, Melissa. But even with your one pager that you have here, this is so easy that you could put background or why is it important, right? That's your and statement, like you were saying, and then you put the problem, which is your but statement, and then your therefore is the solution. You know, so you could easily turn this into the problem, or sorry, the background, the problem, and then the solution. And people understand that. Like they understand why is it important, what is the problem, and what can you do about it. And most of the time, the action or the solution is your audience wants to know how they can help. What is their call to action, right? You can say the solution is that we need more research and we need to advocate for more research or more research funding in this area, right? Because we don't know. But you want to connect your action to your audience as well, of like what should they do about it. And that's a really great way to tie that link and to make your audience the hero of the story. And with your help, we could do this. Or we just want you to know that it is a problem because a lot of people don't know. And that's also okay as an action as well.
All of these resources are in the folder, so you can take a closer look to the one pager and build your own. Basically, I wanted to share with everyone.
Yeah, so we shared this document here. It's very fancy, but it's essentially like the one pager that Melissa had. What is your and, what is your but, and what is your therefore? Or your introduction of your problem. Why is it important? What's at stake? What's at stake meaning if we lost it? Why do we care if it's there or not? Or why is it a problem? What is your research question or your knowledge gap? And your therefore is how will your work fill that knowledge gap, or what action do you want from your audience? And this is just a template we threw together based off of Melissa's one pager, but it can be very effective. And you can just use this information here in any conversation that you have. So it really does help with how you talk to people, how you introduce yourself, how you present yourself, how you present your ideas, because it's very structured of I need to provide them this information, then this information, then this information. So I can help you with all of those crazy, erratic thoughts in your mind that you want to share with everyone.
I know that we are kind of late on time. I don't know, Heather, if we can take questions, or we can pass to the happy hour, or if someone wants to share a message, we can provide you feedback online, or just email us and we can help you out.
Yeah, if you'd like to spend 10 or 15 minutes in smaller groups to work through this, or we can just go right into kind of a Q&A session before having a little happy hour gathering with.
What do you think, Keisha?
Oh, like we could do either. I'm ready for both. Also, if people have like an ABT or a theme, it's also what I spend a majority of my time doing is just restructuring people's sentences or their ideas too. Or questions.
Let's open
Got
for
a pretty
questions.
quiet audience.
I know.
I had a question, maybe. Can you hear me?
Yes.
Yeah.
So I looked at the worksheet, and with that format, it's like you want to stick to 1A, 1B, 1T, and then especially with the worksheet, cutting it down to like 5 words for the 5-word problem. So say like with my research, there could be 2 that, it could be the problem is sparse data, the problem is a different one. You want to choose one. So one of the speakers said if you had to do that, just have it like 2 ABTs entirely. I don't know. I'm trying to figure out how to choose. Like, I guess it depends on the audience which one to choose, but is there a way to present 2 at once? Because maybe one problem would appeal to someone in the audience and one problem would appeal to another. I don't know if that question's too like abstract. I'm also really tired. I have a new puppy. I might have to jump off at any point, but I'm just wondering if you had any guidance like related to that.
Yeah, that's a great, Kayla. I get that question a lot because I think we think adding more problems makes our research even more important, right? Or sometimes we're like, we don't know.
Stop it. Oh my God, I'm so sorry.
No worries. Or we also don't know which problem is more important to who, right? So exactly what you're saying is your problem you want to present could be dependent on the audience that you're talking to. And the audience will, because you want that action, right? You want something from them or you want to have something come from the conversation with them, right? But the problem also should be the problem that your work is directly identifying. So a lot of the time students say the problem is we don't have data or we don't have enough data. So then I ask them, well, are you generating more data to fill that knowledge gap? And they say no. I'm like, well, that's not your problem then, right? So you want to make sure that the problem you're putting forward is actually a problem that your work is addressing or a problem that you want the audience to do some type of action for. Does that make more sense, Kayla?
Yeah, I guess the audience putting it in the one that chooses something that's more actionable for that particular audience rather than just like relevant or interesting to them that's really helpful.
Yeah, that would be the way I would go when talking with someone. Obviously, for your research or writing a manuscript, both of those things can be problems, right? That you're introducing in your manuscript or in your presentation, and you want to present both of them, but I would just approach them. I would introduce one, and then I would introduce the second one. And I also have my students, this is like the next level, we do an and, but, therefore, and then we do a but, therefore, right? So, because sometimes the and statement sets up both problems, so you can make a nested ABT inside of each other to introduce one problem, therefore we need to solve it this way, but there's also another problem with how to solve it, therefore we need to do this thing as well.
Oh yeah, okay, that super helps. Thank you.
Yeah, I know it's kind of hard to get into all of the details and nuances of it in like 30 minutes, but I'm glad you already started looking at the worksheet because this kind of walks you through. You have your ABT. Let's first start with your problem and your 5-word problem. And the first thing is making sure you just have one problem. But you can build on the ABTs once you feel more comfortable constructing a narrative first.
Yeah. Just last comment. I feel like almost sometimes I am thinking of one and it seems like there's one ABT that helps to lead with, and then like when you're kind of at the conclusions, there's like a separate ABT that like after you've given the context, maybe you can use it. Yeah, different steps, different phases.
Yeah.
Thank you.
Yeah, I'm glad you asked that question because that's a really great question.
There are two more questions here in the chat. One from Zach Gold. In this era of strong science misinformation, have you found the ABT structure been helpful or useful for overcoming barriers of basic understanding?
Great question. Yes, we have found that having clear ways of presenting information is helpful for people understanding it. But we've also found, I haven't done this work, but Randy Olson has found that those who have a strong narrative message appeals to the masses. And what we do as scientists is we don't have a narrative message because we haven't been taught that, right? We don't have a lot of background in understanding story structure and communication theory. So our information is very and we're providing more and more information, right, to back what we do. And if you have a narrative structure, that appeals to the audience or a larger audience because they understand it easier because that's how mass media communicates with everyone. They have a setup, problem, solution, right? So folks have used this communication structure to really communicate misinformation very fast. So how it's been really helpful, but then people have used it actually to provide more misinformation to folks because they want to know information. They want to know the what immediately. They want to know what the problem is and they want to know the answer, right? Everyone is very impatient.
And I want to mention that this is very important, especially now that we are talking about all of this marine carbon removal techniques and how different can sound if you don't really give the right message or have the right words to explain what you're doing and what the technique is. So we have a couple of like communication workshops just to try to overcome these barriers and misinformation to the public.
And even just within the disciplines, like I see like the next questions about talking with policy. The issue is we all talk our own type of language, right? In our intergroups, and being able to just talk across disciplines, we need to have some kind of common knowledge where we take it out a step to our outer group and be able to talk with each other. And this is a great way of doing that because I work with engineers a lot and they immediately dive right into the details, but I don't understand the context of those details. But if we just bring it out a little bit, and we call this, distilling, some people call it dumbing it down, but it's not really doing that. We're just bringing everything up a level so we can all have communication at the same level before going back into the details. So I think that would just be really helpful with marine carbon removal. There's a lot of different disciplines involved. And if we jump right into the details, the and, but don't structure it with, you need to know this background information to understand this problem, to understand this should be the solution. Like that could be a lot more effective in how we work together across disciplines.
I also want to mention, Kayla, that in my one pager, I wanted to also highlight some of the other work that I was doing with developing technology. So I just put a picture of the technology that we're using, and we just highlight kind of like we use technology to answer these questions at the University of Hawaii. And that way I didn't really provide any details on that, but give a hint to the person or to your audience that you are actually working on that, and they can ask you more questions if they want more details.
That's great. If we don't have time to make our one pager today, are any of you available later on in the conference to like kind of look over and like give feedback if we developed one in the next like 2 days, or just an email, I guess?
Definitely. Yeah. Please send me your ABT. I'd be happy to look at that.
Yeah. And we'll be like all this week with OCB. So
okay, thanks so much.
Yeah, happy to help. And I know that like some people have this criticism that it's too broad sometimes, right? You want to present all of those details and that information. But I think the important thing to think about is this is just the starting point, that you present this information, you tell the people the information they need to know, what the problem is with the solution, and then they gives them an opportunity to ask more questions and make it more of a dialogue. Because I think people want to provide all the information so people have all of it, but more of this conversation with people outside of our expertise is about a back and forth and an understanding and a conversation. So this is us just taking a different approach of how we communicate with people from different expertise, and especially with the public. So in my class, we really focus on having a connection and having a dialogue with the public so that there is a trust that's built so they can ask questions and be at the same level regarding what we're talking about, instead of just throwing all this jargon at them. Because as soon as somebody hears something that they don't know or something that it contradicts their values or who they are as a person, they completely shut down, and then you lose them. So I think just even knowing that and understanding that and being aware of it allows you to have a stronger connection or at least knowledge of how you can talk with people in other circles. And it's so simple.
Yeah,
Sorry.
that's a great point, Keisha, because I knew that I was going to present to senators from Hawaii. So I put in my one pager, I'm working with Hawaii.
Yeah.
And I put like how Hawaii ecosystems are being affected. And that's the connection. That's the connection with them. I work in your state.
I'd like to come back to the question Jillian asked in the chat here, just in a little more depth. Do you recommend the ABT structure for more policy applications or description to a more general audience, or also for a more scientific community? I'm thinking about the what, how versus the how, what example for what format is best depending on the audience.
The answer is yes for all of them. What I found is your inner circle is a lot smaller than you think it is. It's really the people just sitting next to you in the building, right? So even within the scientific community, if we get better at presenting information, it can be more detailed, but presenting information that allows presents the context of the problem and then introduces the problem and then the solution, then we understand in our different expertise, like, oh my gosh, you're right, that is a problem. Never thought about that before. So it helps with clear communication, and it makes things easier to read, makes easier to communicate with each other. Definitely, it's all of those things. So we do that. We focus primarily on the outer group, or sorry, on the public, because that's usually a bigger distance for people to try to make those jumps, like what words to use, how to use the words. But your inner group, you just, once you have the structure, it's just copy paste, right? It's ingrained in you. So you just start talking literally in ABTs. My students all talk in ABTs now. They write their emails in ABTs. You know, it's really funny. The structure, it doesn't always have the and button therefore, but there is a setup, what my problem is or what I need, and then the solution.
So Emily follows up with a question in a presentation. Say you have around 3 ABTs. Do you just present each sequentially or try to tie them all together? And I think you kind of started to get at this when you were giving advice to Kayla before, but I don't know if you want to elaborate any more on that.
Yeah, I've done both. So this is a advice I give for people presenting their theses or their dissertations, because they usually have 3 questions, right? So what I usually do is I have them introduce an overarching ABT, because there's usually some theme that they're talking about. And for me, it's always coral reefs are dying. So we introduce like corals are important, but they're dying. Therefore, we're doing X, Y, and Z to help them. And that introduces your next ABTs, your 3 ABTs. So you're like, okay, first, let me tell you about this thing, this ABT. Okay, now that we learned about that, let me tell you about this next ABT. And then now you know about that, let me tell you about the final one. And the way that you structure that can be just overarching ABT, your 3 ABTs, or you can do an overarching ABT and then an ABT that has a similar background for all 3 problems, but you just introduce them kind of like the but therefore I was talking about before. You have your and for the overall context that people need to know, and then your but this is a problem, therefore I did this. But this is also a problem, therefore I did this. That one's a little bit harder because your questions would have to be very similar. Like there's always a way that you can set up your problem in a more specific way that makes that problem more, it makes your audience realize that that's a bigger problem, right? Just saying that coral reefs are important and we value them, but we don't know if there's solutions, right? There's other ways to set it up, but we don't know how they calcify, but we don't know why they bleach, right? You can provide more information about what we do know about calcification and why it's important, or what we do know about coral bleaching and why it's important for corals to have their color. And I'm sorry, it's also late in the day, but I'm like, I can't give any other examples besides corals right now. But you can see like there's more specific context to provide for each of your questions to set them up to allow for it to be single ABTs. And it's easier for your audience to understand and follow your presentation. And it's also easier for you to give the presentation. These are all really great questions.
Well, I want to thank both of you for all the time you took to pull this together and for sharing those great resources. It was really, I mean, I know it was a short period of time, but it was a lot of amazingly useful information packaged just right. So thank you again so much for this, and glad to know we'll have both of you throughout the week, and Keisha's going to be speaking in the rapidly changing systems session on Friday. So we'll get to hear more about her corals.